Seconds. We're live. Okay. So we're going to be talking about the geometric distribution, or geometric sequences, I should say. Geometric sequences. Okay. So the geometric sequence is given by the formula A sub n equals A, or A sub 1. I'm going to put a 1 there, even though I don't have it in the formula. R to the n minus 1. Okay, so that's your formula that you're going to need to know for this section. So let's say that we'll do an example here. Let's let A equals 3 and R equals 2. Okay, so using this formula, well, A sub 1 is going to equal A, which is going to be your 3 times 2 to the 1 minus 1 power. Okay? What's 2 to the 0 power? 1. So 1 times 3 is 3. So A sub 2 equals 3 times 2 to the 2 minus 1 power. 2 minus 1 is 1. 2 to the first power is 2. 2 times 3 is 6, right? A sub 3. 3 times 2 to the 3 minus 1 power. Okay, let's pick on Spencer. 3 minus 1 is?
That's 2.
2. So 2 to the second power?
4.
4 times 3?
That's 12.
12. A sub 4 equals, Julia, can you help me plug in this formula?
3 times 2, and then the 4 minus 1.
4 minus 1. 4 minus 1 is?
3.
2 cubed?
8.
8 times 3?
24.
24.
Yeah, that's right.
So can you see in here, we're basically taking the first number and we're multiplying it times 2, times 2, times 2. You see that? Okay. So remember, with the arithmetic distribution, we had a common difference. In this case, we have a common ratio. Okay. So the next one, even if without doing it, I'll bet you that Victor, A sub 5, you could figure out what it was. 48. 48. Or just multiplying it times 2 again, right? But if we did it again, 3 times 2 to the 5 minus 1. 2 to the 4th power is? 16. 16 times 3 is 48. Okay, does that make sense? So, whereas the arithmetic has a common difference, the geometric has a common ratio. Okay? All right, let's do another one. If I had 2 minus 10, 50, negative 250, and 1250, first of all, can you tell that that is a geometric sequence? Kelly?
Yes.
Yes, your common ratio in this case is going to be
Negative 5.
-5. Now, could you come up with a formula like this? A sub n. What was your A? What's your first term?
2.
It's 2. So A sub n would equal
2 times negative 5 and minus 1.
n minus 1. Okay? It's terrible looking too, but there you go. Okay, so there is your formula for A sub n. That make sense? Okay? How about if I have a sequence 1, 1/3, 1/9, 1/27th, 1/81st, etc. Cameron, Indoor Stadium. Can you tell me, does that look like a geometric sequence to you?
No.
Yes.
Or yes.
It does, right, because we're going to multiply each term by
1/3.
1/3. Okay. So can you come up with this formula here?
Yeah, so it'd be 1 times 1/3 n to, or n minus 1.
Minus 1. Okay, does that make sense now? Okay. All right. Okay, let's do this one. What if I had 5, 15, 45, 135? Jonathan, can you see, does that look like an arithmetic or geometric sequence?
Geometric.
Geometric. So R equals 3. So your formula is going to be?
A sub n.
A sub n equals?
5 times 3 to the n.
5 times 3 to the n minus 1. You guys are getting good at this. It's going to be so easy, you're all going to get 100 on my final, right?
Wait, so how do you figure out R?
How do you figure out R? How did you figure out R, Jonathan?
Because since I knew that 5 times 3 is 15.
5 times 3 is 15. 15 times 3 is 45. 45 times 3 is 135. You're
How
looking
did you
for,
figure out on 2 to negative 10? Is that just, oh, okay, I see.
see it now? Okay. All right, well, we got to get a harder one now. We're getting too easy. We can't have all easy problems on the final. What if I said that the third term of a geometric sequence is 63 over 4, and the sixth term of a geometric sequence is 1701 divided by 32, and I say find the fifth term. Okay? Angel, it must be your turn. Any ideas how you would do that?
It's geometric, then I would line them up.
Line them up? What does that mean? Yeah, let's see if we can see a pattern. So a sub 3 equals
63 over 4.
it equals 63 over 4, and if we were to write it in this form here,
That'd be,
we don't know what a is yet, do we? It would be a times r, which we don't know yet either, to the
3 minus 1.
3 minus 1. Okay? And a sub 6 would be
1701 over 32 equal to a sub 1 r 6 to the 6 minus 1.
6 minus 1. Okay? So essentially what we could do is if we divided these two, right? The a's would cancel. This is really r squared, and this is really r to the 5th, right? Okay? So the a's are going to cancel. I'm going to be left with r cubed equals, now I've got, what I'm going to do is I'm going to invert multiply. I've got 63 over 4, and I've got 1701 and 32, right? 4 goes into 32 8 times. And I have a feeling that those two are going to go into each other. Don't know that one off the top of my head.
How do you get R cubed?
This is r squared. Oh, sorry, it's 1 over r cubed. I've got r squared divided by r to the 5th. Right? Okay. It's 27. It is?
1701.
Oh, yeah, it's 27 over 8. Okay? So essentially, here, let me rewrite this because I know it's messy. So essentially, I've got 1 over r cubed equals 8 over 27, correct? Or I could say that r cubed equals 27 over 8. Everybody agree with that? You just flip the reciprocals?
So you just divided those then?
I just divided these, that's correct. Okay? So the cube root of 8 is 2, and the cube root of 27 is 3. That's going to be your r, right? So your ratio is 3 over 2. Correct? Okay? Now that we've got our ratio, we can plug it back into our original formula and see if we can figure out what a sub 1 is. We want a sub 5 equals a times 3 halves to the, well, actually, there's probably a better way to do this. 5 minus 1. If we know that the ratio is 3 over 2, I could either take a sub 3, which is, what is it, 63 over 4. I could multiply it by 3 over 2, which would give me a sub 4. 3 over 2, sorry. Which would give me a sub 4, and multiply it by 3 over 2, which would give me a sub 5, correct? Does that make sense? No? You understand here, let's go back to this one here. Well, you've got a common ratio, right? You take the so you can think of this as recursion, right? If I take the first term and multiply it by a third, I get the second term. Multiply by a third again, I get the third term. Multiply it by a third again. If I start with a sub 3, and I know the ratio is 3 halves, this is a sub 4. And this whole thing is a sub 5. Okay? So that gives me 567 over 16. Okay?
I'm lost with how we can interact a sub 3 with a sub 6. You divided them or you subtracted
Right.
them?
We divided them because we're trying to find, because when we divide them, the a's drop out, correct?
Yeah.
If the a's drop out, then I've got r squared divided by r to the 5th, which gives me r cubed, 1 over r cubed, right? Which equals 8 over 27, which I really here, there's a horse confusion there. Okay?
Can you do any 2 things in the sequence? So like you did 3 and 6 and you got the ratio. Could you do like?
Could we figure out what a sub 1 is? What would a sub 1 be?
Probably.
It's going to be 3 halves to the 1 minus 1 power, right?
Yeah.
And then what?
So it's just going to be 1. Oh yeah, we're missing a.
We're missing a, aren't we? Why am I?
Well, a sub 1's already in.
Oh, we could also plug it into here, right? We could plug it into here. If we know what a sub 3 is, a sub 3 equals 63 over 4 equals a times 3 halves to the 2nd power, correct?
And that would give you a sub 1.
Because this is a sub 1, right? Now I just have to solve for a. How do I solve for a? I'm going to multiply this by 4/9, right? That will cancel that, and that will cancel that. Correct?
Yeah.
So that means I can multiply by 4/9. The 4's canceled, the 9, so a becomes 7. So that's your a sub 1. Does that make sense?
So, but in order to find the ratio, could you do any one in the sequence? So like you could do a sub 4 over a sub 10.
Yeah, these terms don't matter But they are gonna have a common ratio.
Okay, so you just
And so you can divide them, to find out what the common ratio is, because the a's will drop out. And then you can use either term. This one's clearly the easier term to use to figure out what your original term was. Okay? Does that make sense? All right, so let's go back over here. And the other thing that we're going to want to know is partial sums. So the sum on the geometric series. Okay, so we're going to use sum for S of n equals a times 1 minus r to the n power over 1 minus r. So that's going to be your sum. Okay? So what if I said find the sum of 1 plus 4 plus 16 plus dot 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 plus 4096. Okay? So one way to write that would be the sum of a times r to the n minus 1 from 1 to, now we have to figure out what is this number 4096? Which term is that if this is a geometric sequence? So that we can figure out what this number is here. Okay? How do we do that? It must be, I think I haven't picked on anything yet.
just divide it by 4.
So we're going to use this formula right here, right? So a sub n, we don't know what n is yet, equals the first term, which is 1, times what's your common ratio? 4 to the n minus 1 power, right? Okay. Well, I thought there was a better way to do that, but that's, I'm looking here at the book, and there's not a really good, they know clearly 4 to the 6 is 4096. So therefore, what's, which term is that? If n minus 1 equals 6, what's n? 7. Right? So if we do the sum from 1 to 7 of, in this case, your a is 1 times 4 to the 6th power, okay? The easiest way to do that, without listing all the numbers, is I can use this formula here. So that's going to be 1 times 1 minus 4 to the 7th power divided by, 1 minus 4.
Is that how you find the ratio, or is the sum?
This is how we're going to find the sum. Okay? 4 to the 7th power I don't know what that is. But clearly that equals 5461. Just plug that in your calculator. Okay? Do you guys want to check the calculator, make sure you got that same number? What is 4 to the 7th?
Probably 4 times.
A big, very negative number. It's 1 minus, no, it's got to be more than that. It's 496 times 7, or times 4.
Yeah, 12,000.
Yeah, it'll be negative and negative, so they'll cancel and it'll be
Oh,
positive.
yeah. So it's 800
What is
is
it?
the sum.
4 to the 7th is what?
Oh, for the 7th, that's 2401.
2401? What?
Pretty sure.
No, that can't be. It's gotta be greater than that. It's gotta be 16,000 or 17,000. What is it?
16,384.
1 minus 16,384 over negative 3, which equals 5461.
This is the next one. Yeah, 1638.
Okay. All right, does that make sense? Okay, let's do it again. Probably should have started with this one. This one's probably a little easier. Okay, the sum from k equals 1 to 6 of 7 negative 2/3 to the k minus 1. Okay. So how would you set this up? Who haven't I picked on? I think I've picked on just about everybody, haven't I? No, Victor, I haven't picked on you.
So, what's the new formula?
The sum formula's right here.
That's
So what's your first term?
7.
First term is going to be 7 times
1 minus r, which is negative 2/3
negative 2/3 to the
to the
6th power,
6.
okay, over
1 minus negative 2/3.
negative 2/3. Okay? So this becomes 1 plus 2/3, which is 1 2/3, or 5/3. And on the top, I'm going to get negative 2 to the 6th power, 16 to 64, over 3 to the 6th power. I don't think I know that one. 3 to the 6th power is 729. And I'm going to get 1 minus that. So this is going to equal 931 over 243, which is roughly 3.83. Okay? Knowing the math department, well, they'll probably be okay with that. But I am going to want to see your work there. Okay?
Isn't that also multiplied by 7?
Yeah, multiplied by 7. Yeah. Oh, sorry. You're right. I need this multiplied by 7 also. Yes, that's correct. Okay. Now, let me add one more formula here. If the absolute value of r is less than 1, then you can use the sum equals a over 1 minus r. And we would say that it converges. Okay? Now, here's one of my favorite things to do. Oh, I'm surprised it's not a problem in this book. I'm really surprised. I'm going to do this one. Show that 0.99999 equals 1. Okay? Now, here's how we can do that. We could rewrite, and I'm going to put dots here, okay? We could write this as a geometric series. This is 9/10ths plus 9 100ths plus 9 1,000ths plus 9 10,000ths, etc., right? Do you agree with that? Okay. So could we come up with what's your common ratio and what's your first term?
So the ratio is 1/10, right?
Your ratio is 1/10.
And our first term is it 9/10 or is it 1?
I think it's 9/10. Okay. Now, how would we make our formula? So A sub n would equal 9/10 times 1/10 to the n minus 1, right? Let's make sure that gives us the right thing here. Okay? So I've got anything to 0 power is 1. 1 times 9/10 is 9/10. 2 minus 1 is 1. 1/10 times 9/10 is 9 100ths. Okay? So does that make sense?
Yeah.
Okay? Now I've got a common ratio that's less than 1, correct? Okay? So according to this formula, I can use the second formula, correct? And we will say that it converges. Let me just also add, if the absolute value of r is greater than 1, then it diverges. Now, we know that 0.99999 is really close to 1. But I'm going to show you that these are actually the same, according to this formula, okay? The idea here is I'm going to take your formula S equals your first term, which is what? 9/10 divided by 1 minus your ratio, which is 9/10, 1/10. This equals 9/10 divided by 9/10, which equals 1.
The math is broken.
Isn't that kind of cool?
Is that why we round?
Okay. If I just put as many of these things here, we're so close to 1 that it's actually 1.
Isn't that like technically just infinite max?
This is an infinite series, right? And so what this is saying here, this happens anytime your ratio is less than 1. It's going to converge to some sum. Okay? Let's do another one. What if I had the infinite series 2 plus 2/5 plus 2 25ths plus 2 1/25ths, okay? Plus forever on, okay? We're never going to stop, okay? So Berkeley, what would be your common ratio?
1/5.
Common ratio would be 1/5, correct? Okay, is that less than 1?
Yeah.
So does it converge?
Yes.
Yeah, so we know that because my ratio is less than 1, it converges. So which formula can I use?
S equals A over S.
S equals A over 1 minus R. A in this case is?
1. Wait. 2.
2 over 1 minus
Whatever fits.
1/5. So 2 divided by 4/5 is the same thing as 2 over 1 times 5 over 4, which is 10/4 or 2.25.
Isn't it 2.5?
2.5, you're right. Okay? This sum will never, we started at 2, it's never going to get more than 2.5. Okay? Does that make sense? How about if I do this one here? Um, 1 plus 7/5 plus 7/5 squared plus 7/5 to the third power. What's your common ratio? 7/5. Does it converge or diverge?
Diverge.
This one's going to diverge. Okay? So one way to think about this is you've got 1 plus 1 2/5 plus, what's 49 over 25? That's about 2 point something plus 3 point something. Is this ever going to get to a common sum? It's going to just, the sum is going to keep getting bigger and bigger and bigger. That's what it means by divergence. Okay? So this one, well, if we wanted to do the sum of an infinite geometric series, we're going to have to stop at 50 or some number, right? This one's just going to keep getting bigger and bigger. Whereas this one will always converge to some number. Does that make sense? You understand the difference between converge and diverge?
Yeah.
Okay, well, I haven't picked one yet. All right. All right, so one other thing that we can do, maybe I'll keep that there, is we can find the fraction for a repeating decimal. Okay, let's say that I have the fraction 2.3, or the decimal 2.351, and the 5 repeats. Okay? Now, I could represent this as 23 over 10 plus 51 over 1,000 plus 51 over, I have 2 more zeros, right? 100,000 plus 51 over 1, 2, 3, 2 more. Okay? Now, if I ignore this piece here for a minute, okay? Let's just look at these. We can treat this plus, etc., right? If I ignore this one, what is your common ratio?
1 over 100.
1 over 100, right? Okay. So, what is my first term? 51 over 100. We're ignoring this. We're going to ignore that for just a minute. Okay? So, in this case, does this converge? This sequence here converges, right? So which formula can I use? The bottom one here, right? So in this case, I've got 51 over 100, over 1,000, excuse me, over 1 minus 1 over 100. Correct? Okay. Which is 51 over 1,000 over 999 over, sorry, 99 over 100. Okay? I can flip and multiply, and I'm going to have 100 over 99, right? So those 2 zeros cancel those 2 zeros. And I'm going to get a fraction of 51 over 99. correct?
What do you mean?
Maybe
999?
990. That's what I meant. Okay. So now I can take this first term, 23 over 10 plus 51 over 990. I can get a common denominator, which is 990, right? So if I multiply this by 99, 99, that will give me 2328 over 990. And of course, everybody knows that simplifies to 388 over 165.
Wait, why did you
I would totally be fine with that though,
why did you times 23 over 10 by 99?
because I was trying to get a common denominator here.
Oh,
Okay? Does that make sense?
yes.
Okay? All right. Well, that's the end of 8.3. So now let's move on to 8.6. Which is binomial theorem. Okay, so, Caitlin, I haven't picked on you. If I had the factors a plus b and I wanted to FOIL that out, do you know what you would get?
So you get a squared plus 2ab plus b.
Okay,
Yeah.
well done. Do you know what you would get if we did a plus b cubed?
You'd get a lot more numbers than that. You'd get.
Would you like a good way to figure this out?
Can't we just take the one we have
Why don't you
already?
just have a cubed?
You could take this and you can multiply it by a plus b, right?
Yeah.
Okay? So this is going to give you a cubed
plus
cubed.
a squared.
plus
Oh.
2a squared b
And
plus ab squared plus 2ab squared plus b cubed. Right? Let's see.
So where should have?
So we can combine these two, right?
Yeah. We can combine those. So
What am I missing? I'm
it's
missing something. A cubed plus 2a squared b plus ab squared plus, oh, I forgot one. Plus
yeah,
ba
there's supposed to be
squared.
an a squared b.
Ba squared plus 2ab squared. Oh yeah, I forgot one term. Okay, so I can combine these two here, and I can combine this one with this one, right?
Yeah, there you go.
So this becomes a cubed plus 3a squared b plus 3ab squared plus b cubed. Okay. Now, okay. So what I'm telling you is I could have gone straight to there. And in fact, I'm going to do a plus b to the fourth power. And I'm going to do it all in one step. It's going to be a to the fourth plus a to the third b times 4 plus 6a squared b squared plus 4ab to the fourth, b cubed, sorry, plus b to the fourth. And in fact, I can do the next one. A plus B to the 5th power. Okay? This is where I become the math magician, right? How can I do all this in my head? This one's going to be A to the 5th plus 5A to the 4th B plus 10A cubed B squared plus 10A squared B cubed plus 5AB to the 4th plus B to the 5th. And that is the correct answer. How am I doing this magic?
It's mirrored, right?
It is mirrored, and that is a very good observation.
And then you're adding spaces for each exponent you're going down.
Mm-hmm.
So do you do for the first one that has the 5, you just.
Do you want me to do can you do A to the 6th? Are you seeing a pattern here?
I think so.
Okay, what's the pattern you're seeing? A plus B to the 6th power.
Okay, so you do A to the 6.
A to the 6th.
And then you do plus 6, A
6.
to the 5th,
A to the 5th B.
plus, and then you have to add all of those. So
Is it 12?
30?
To the 4th?
Is it 30? I think you're adding all of the.
It's 15.
It's 15.
Okay.
Oh, so you just add those two on that.
Ah, you did. You
Okay,
just
now I
figured it out.
see.
Yep. We're adding the 5 and the 10.
Okay, so you're not adding all of
15.
those, it's just the ones on the
Okay.
side. Okay.
So here's the trick. We got a thing, and it's called Pascal's Triangle. So Blaise Pascal figured this out, and here's how it works. 1, 1, 1, 1, 2, 1, 1, 3, 3, 1, 1, 4, 6, 4, 1. The idea here is with Pascal's triangle is you take these two and you add them. 1 plus 2 is 3, 2 plus 1 is 3, 1 plus 3 is 4, 3 plus 3 is 6, 1 is 4. Okay? So now the next line will be 1. We're going to add these two together to get 5, 10, 10, 5, and then 1. So we just put 1s on the ends. Okay? The next line on Pascal's triangle will be 6,
15,
15,
15. Oh, sorry,
20,
15,
15,
1. Or
6.
6. Sorry. I
And
don't
then
know
1.
again.
Okay? So, yeah, let's finish this off. A plus B to the 7th. Well, the easiest thing to do is to keep going one more line, right? Okay? So Pascal's triangle, we'll do Pascal's triangle and then we'll do it over there, okay? So this is going to be 1, 7, 21, 35, 35, 21, 7. Okay, so to formula out A plus B to the 7th, sorry you can't see that on the board, but you guys would trust me. So vertically, this would be A to the 7th plus,
7, 8,
you're just going to subtract 1 every time.
6.
6 B to the 1st, right? Because these all have to add up to 7. Okay, plus
21.
21, so we're going 7, 6, 5,
5.
B
4.
squared. These always add up to 7. Everything adds up to 7. All the exponents add up to 7, okay? Plus, the next number is 35. A to the
2.
7, 6, 5,
4.
4. B to the 3rd. Plus
35.
35.
A to the 3rd.
3rd.
B to
The 4th. Plus
21.
21.
A 2.
Squared. b to the
Set 5.
5 plus
7.
7
A.
a b to
B
the
to the 6.
6 plus
B to
b
the
to
first.
the 7.
Oh, so,
Okay, does that make sense?
Yeah.
Don't you feel a whole lot smarter?
Oh, no.
You feel like a math magician now, right? All right. Okay, so let's make it a little bit harder, because, it's a math class, we can't make it all easy. Okay? What if I said that I want you to expand, we did there, expand, in this case, 2 minus 3x to the 5th power. Okay? Now, who would like to FOIL that out 5 times? Who would like not to FOIL that out 5 times? Okay? All right, so let's do the same thing. A in this case equals 2. B in this case equals negative 3. I'm just going to leave it as negative 3 for now. Okay? You do need the x in there, but we're going to ignore the x for a moment. Okay? Or do I want to keep that in there?
Okay, can I get it?
No, I do want to keep that in there. I changed my mind. You want to do this?
Yeah,
Okay?
so it's 2 to the 5th.
2 to the 5th plus
Okay, 5, 2 to the 4th.
5 times 2 to the 4th
Negative 3x.
times negative 3x
Plus 10 to the 2 to the 3rd power.
10 2 to the 3rd power.
Negative 3x.
You're still using x plus negative, or times negative 3x squared.
Yeah. But then plus
Plus
10,
10
2 to the 2nd.
2 squared.
Negative 3x to
Negative
the
3x
3rd.
to the 3rd.
Plus 5
5
times
2 to the
2.
1st.
Negative 3x to the 4th. And then negative 3x to the 5th is the last one.
Okay? Well done. Okay, pretty cool, huh? Pascal's triangle right there. So 2 to the 5th is 32, plus 2 to the 4th is 16 times 5 is 80. And then it's going to be negative, times 3 is negative 240, right? Negative 240x. Right? Now, plus 2 cubed is 8 times 10 is 80. Negative 3 squared is 9. 80 times 9 is 720. X squared. Plus 2 squared is 4 times 10 is 40. Negative 3 squared is negative 27. So that's going to be a negative. 27 times 40, I don't know what that is. 27 times 40, 8, which is 10. 1080, and it's negative 1080 x cubed plus 81 times 10 is 8100 x to the 4th. And then this is going to be a minus 3 times 3 is 9, 9 times 9 is 81 times 3. 81 times 3 is 243. X to the 5th. Okay? That was a lot better than foiling that out, right? Foiling that out, you'd run out of time on the final, right? Okay?
So with Pascal's triangle, we're always pulling from those numbers, right?
Mm-hmm.
We don't have to do the triangle on the other side every time?
Well, so the idea here is, let's talk about the binomial coefficient, because you just went right where I was going. Okay? Because after a while, who wants to write this down a bunch of times, right? Okay? So the binomial coefficient is written as n choose r, which equals n factorial over r factorial n minus r factorial. Okay? So, now let me just give you, you guys know what 4 factorial means? Exactly. 4 times 3 times 2 times 1, which in this case would equal 24.
Is that n over r?
N over r, yes. Okay? Now, trick question, what is 0 factorial?
1.
It's 1. Why? Because we said so. We need it to be 1 to make math work, okay? So the idea here is this all leads to the binomial theorem, which is what we're really getting into now. Okay? Because nobody wants to remember Pascal's triangle every time. Okay? So if I have a plus b to the nth power, that equals n choose 0, a to the n plus n choose 1, a to the n minus 1, b to the first, plus n choose 2, a to the n minus 2, b to the second power, plus etc., until you get all the way down to n choose n, b to the nth power. Okay? So one way to do this, so that's your binomial theorem. That's what this whole thing leads up to. Okay? We're going to be able to expand these out for any n. Okay? If I wanted to do x plus y to the 4th power. Okay? And I didn't want to remember what Pascal's triangle was. Okay? Essentially what this means is you're going to have 4 choose 0, x to the 4th, plus 4 choose 1, x to the 3rd y, plus 4 choose 2, and I don't want to put a divide there, I keep doing that, x squared y squared, plus 4 choose 3, x y cubed, plus 4 choose 4, y to the 4th. Okay, does that make sense so far?
What is the n choose r out?
Okay, so that's what we're going to do right now. Okay, what does this mean? Okay, we're going back to this definition. Okay, so what this means, the coefficient of your x to the 4th term is going to be 4 factorial over 0 factorial 4 factorial. Okay, and you know what 4 factorial means, right, Jonathan? You know what 4 factorial means?
Yeah.
Okay, so the nice thing about this is the 4 factorials cancel. 0 factorial is 1, because we don't want to multiply this by 0 or it'll mess it up, okay? So this just becomes simply x to the 4th. Okay? Now, we can do the next one, which is 4 factorial over 3 factorial 1 factorial. Well, one thing I could do is I could write 4 times 3 factorial, right? The 3 factorials cancel, and I'm left with 4 over 1 factorial, which is just 1, right? So this is 4 times x cubed y. Does that make sense?
I don't know what we're doing with it.
All we're doing is we're going crazy with this binomial coefficient over here, okay? The idea is we're trying to figure out what are these coefficients without doing Pascal's triangle. Okay, so right now, you know it's going to be 1, 4, 6, 4, 1.
Yeah.
Okay, because we did that with so I already know it's going to be 6x squared, y squared, plus 4xy cubed, plus y to the 4th. I already know that from Pascal's triangle. What I'm trying to do is, so that you don't have to memorize Pascal's triangle, I'm trying to figure out what these coefficients are without using Pascal's triangle. Okay? And so this is another way to figure out Pascal's triangle. And believe it or not, this is actually going to be easier. Okay? Especially if you get up here. Okay, so this next one here, how can I rewrite this? Jonathan?
Would be 6.
This is 4 factorial over
Oh. 2
2 factorial, 2 factorial, right? And I can rewrite 4 factorial as 4 times 3 times 2 factorial, right?
Yeah.
So the 2 factorials cancel. What's 2 factorial? 2. 2 goes into 4 twice. 2 times 3 equals 6. Okay? Anybody going on take statistics? You're gonna use this in statistics a lot. Okay? These are combinations and permutations. All right, so the next one is going to be, how can you rewrite this?
So it'd be 4 factorial.
4 factorial over
3 factorial over
1 factorial, right? And I can rewrite 4 factorial as 4 times 3 factorial, right? So then those cancel. And I'm left with 4 over 1, which is 4. And then finally,
It's just 4 factorial over 4 times 3.
0 factorial, and these cancel. 0 factorial is 1. So much is that. Does that make sense?
Yeah.
Okay. All right.
Can we do that with like a starting one?
A starting one.
Like what we did with the last one, 2 minus 3x to the 5th power. Can we
Yeah.
work from there?
How about if I did this one? I'm going to erase Pascal's triangle so you don't remember it. Okay. All right. So let's. So this formula here that we're working on, the binomial theorem, is basically Pascal's triangle. Okay. All right. What if I said I want you to do the square root of x minus 1 to the 8th power? Okay. Do you want to do it, Spencer?
Yeah, I want to try. So it's going to be
So you want to, A equals in this case,
8, right?
square root of x.
Oh, sorry.
B equals
Negative 1.
-1. Okay. So now let's list out all the terms that we're going to have. And by the way, we didn't expand Pascal's triangle to 8 anyway, so you could figure it out if you did, but let's just go ahead and we'll do it this way. Okay. So your first factorial terms are going to be
So the first one is 8 over 0.
8 over 0, and this is going to be
That's the square root of x.
square root of x to the 8th power plus
8 over 8, 1.
8, 1
And then it's square root of x to the 3rd power.
to the 7th power
7th, sorry. 7th, and then times -1.
times -1 to the 1st power
Yes.
plus
And then 8, 2.
8 choose 2
Yeah, choose 2. Square root of x to the 6th power, and then -1 to the 2nd.
plus
8 choose 3, square root of x to the 5th power, -1 to the 3rd. And then 8 choose 4, square root of x to the 4th power, -1 to the 4th. 8 choose 5, square root of x to the 3rd power, -1 to the 5th. And then 8 choose 6, square root of x to the 2nd power, -1 to the 6th power. 8 choose 7, square root of x, and then negative 1 to the 7th. And then 8, 8 is negative 1 to the 8th power.
Okay. So now we can do some simplifying, right? This is always, so these two terms are always going to simplify to 1, correct? Okay, so I'm not going to worry. So this becomes the square root of x to the 8th power, which is
That's x to the, what, 4th?
4th power, okay? So we've got the first term taken care of, okay? This one is always going to be whatever the top number is, plus 8, okay? Does that make sense?
Okay.
Because it's going to be 8 factorial over 7 factorial, so it's going to be 8.
Okay.
Okay? The rest of them will do the math, but I'm trying to save a little bit. Okay? So this, another way to write x would be x to the 7/2 power, correct? And then this is going to be a negative. Okay? This one's going to be positive. So this is going to be 8 factorial over 6 factorial, 2 factorial. Remember, when you're doing these, the denominator has to add to the numerator, right? Okay? So I'm going to rewrite 8 factorial is 8 times 7 times 6 factorial, so those cancel. 2 factorial is 2, goes into 8 4 times. 4 times 7 is 28. Correct?
How did you do that? That was kind of cool.
Did I go way too fast?
Yeah.
Okay, let's slow down, sorry. Okay, so this is 8 factorial over 6 factorial, 2 factorial. I'm going to rewrite 8 factorial as 8 times 7 times 6 factorial, so those two cancel. 2 factorial is 2. 2 goes into 8 4 times. 4 times 7, 20. Okay? Now, so we're done with this term, we're on this term here, okay? So this is the square root of x to the 6th power is x cubed, right? And the negative becomes positive, right? You can see these are going to alternate signs, right? This negative, all of this negative is going to do is change your sign. So we're done with this one now. This next one's going to be negative. Now, whose turn is it? Julia. 8 choose 3 can be written as 8 factorial over 3 factorial 5 factorial. So I'm going to rewrite this as 8 times 7 times 6 times 5 factorial, right? So then those will cancel. 3 factorial is?
What? Oh, 3 and then 2.
3 times 2 is?
6.
6 times 1?
6.
6. So 3 factorial cancels the 6. I'm left with 56. Okay. I've got x to the 5/2 power. And then the negative I've already taken care of, right? Okay. So then we're over to this term here. Okay. This is going to be x, is going to be plus x squared, right? Now, Kelly, can you help me do this one?
Sorry. So it would be, okay, so it's going to be 8 factorial over 4 factorial, 4 factorial.
Okay, so 8 times 7 times 6 times 5 times 4 factorial, right?
Yes.
So those will cancel.
Yes.
If you look for 4 factorial is,
4 times 3 times 2 times 4.
which is also 24, right?
Yes.
So 6 goes into 24 4 times.
Okay. And then it'll be
4 goes into 8 twice.
So 14.
14.
Okay.
14 x squared. Okay, so we've now taken care of that term. Okay. Plus, no, this one's going to be minus, right? Because minus to the 5th power is going to be a negative. I'm going to have x to the 3/2 power. And then I've got to do this one. So Victor, what does this simplify to?
28.
It's going to be the exact same thing as this, right? 8 over 5 factorial, 3 factorial. So we're left with,
Is that 8 times 7?
yep,
56.
56. Okay. X, okay, so we're now done with this term. Okay. The next one's going to be plus. The square root of x squared is plain old x, right? And that's a plus. So 8 choose 6 is going to be the same as this, which is going to be 28. X. And then minus, wait, we're on this term here now. Hard to keep track of all these, right? So this is going to be 8, right? 8 x to the 1/2 power plus 1. And that's, as Forrest Gump would say, all I have to say about that.
14.
Yeah.
Oh, did I mess up? Yeah, these should be going in order. This 14 doesn't seem right. What
It
did we
should be
do wrong there?
70.
Yeah, it should be 70.
This should be 70. How did I mess that up?
I don't know.
So let's do, which one was that? That was the x, that was this term here. Okay, so we must have done that one wrong. Let's do that one again. I've got 8 factorial over 4 factorial, 4 factorial, right? So 8 times 7 times 6 times 5 times 4 factorial. So that's right there, right? And then 4 factorial can be written as 4 times 6, right? It's 24. So the 6 is canceled. That's why I missed this term here. So 8 times 7 is 56 times 5. 56 times 5, 280. Yeah, that one should be 280. That was the one I messed up on.
Don't you need to divide it by 4 still?
Yeah, divided by 4.
Yeah.
Oh, you're right. Okay. Yeah, 4 times 2 is 8. There we go. 2 times 7 is 14 times 5 is 7. There we go.
Honestly,
I know. If it's 28, I'll go all the way down to 28.
Yeah.
well, can't you?
Yeah, so theoretically, it's nice when you don't have a coefficient here because they should be symmetric here. The problem is when you get like 2x minus 3 or something, then it's harder to check.
Do you have to keep going, like, once you realize it's the symmetric point?
Well, yeah, I remember I went back to these and I got the same coefficients there. Okay. So do you have to keep going? It depends. It depends. If you have a coefficient of 1, then you can just write it in reverse. But if you don't have a coefficient of 1, then
Well, I mean, the 8 over 6 and 7 and over,
Yeah.
that just represents.
these are going to be symmetric actually every time you go.
So like, once I get to like 8 factorial 4, then I would know, okay, that's,
Now you know what those are.
the rest are symmetrical, I just take into account the value.
Okay, so here we go. Let's do this one. Okay, how about this one? This is a good test question. Because probably don't want to go beyond 8, it would be awful, right? What if I said find the term that contains x to the 5th in the expansion of 2x plus y to the 20th power. Okay. So what does A equal in this case and B equal? A is going to equal 2x and B is going to equal y. B is going to equal y. Okay? So Kelly, can you help me with this one?
Yeah. I was thinking it would,
So we want the x to the 5th, and then what's y going to be?
it would be to the 15th.
To the 15th power. Now we just need to figure out what the coefficient is, right? Okay. And you can do your Pascal's triangle down 15 rows, right? But that's kind of a hassle.
So it would be 20 over, what do you, no, 2. Sorry, I'm trying to think.
Here's a
I
hint.
don't know. Would it just be 5?
22 is fine. Okay. So what is that number? So how do I rewrite
So it
this?
would be 20 factorial
20
over 5 factorial, 15 factorial.
5 factorial, 15 factorial. So let's do this. 20 times 19 times 18 times 17 times 16 times 15. Okay? So that those will cancel.
Yes.
5 can be written as 5 times 4 times 3 times 2 times 1, right?
Yes.
5 times 4 is 20.
Okay.
3 times 2 is 6. 6 goes into 18 3 times.
Okay.
So I'm left with 19 times 3 times 17 times 16.
Over 1.
Which you can do over 1, right? Which you can plug that into your calculator, and you will get, theoretically, a mere 496,128 x to the 5th, y to the
So
15th.
do we not have to worry about the 2x at the beginning? Like, because A is 2x. So would we like
Shoot.
times that number times 2?
We do need to worry about that. This is 2x to the 5th, which means I actually need to multiply that by 2 to the 5th,
Yeah.
which is 32. Yeah, which then equals that. Sorry.
Okay.
Yeah. Okay? And then that equals 496,000. Okay?
Great.
All right, how about this one? What if I did x squared plus 1 over x to the 10th power?
Right, you're off the screen. Okay.
And I say, find the x to the 8th term. Now we have a little bit of a problem, right? Because we're going to take the x squared, we're going to multiply it by 1 over x, and whatever we do has to be x to the 8th. And remember, these are going to go up and these are going to go down, right? Essentially. Okay. So we're going to choose 10, choose r, and this is going to be x squared to the rth, and then this is going to be 1 over x to the 10 minus rth. Does that make sense?
Wouldn't R just be 2?
Maybe. But the idea here is, I could rewrite this as x to the minus first power, correct? To the 10 minus r, and then this is x to the 2r. Are you with me so far? Okay. So now I've got a common power, x to the 2r, and then this is going to, I multiply these, and this is going to be times x to the r minus 10. Does that make sense? Okay. So now I can add exponents, right? This becomes x to 3r minus 10. Are you with me?
Yeah.
Okay. And we want this to equal x to the 8th. So 3r minus 10 has to equal 8. Correct? Okay. So if I add 10, 3r equals 18, r equals 6. Does that make sense? So now I can plug r equals 6 into here, and into here, and into here. So this becomes, oh, we're off the board. You guys weren't telling me that.
I
Okay.
told you.
Oh, I didn't hear you. Gotta speak up.
Okay.
Okay, so this becomes 10, choose 6, x squared to the 6th, 1 over x to be 10 minus 6. Okay, so then this becomes 10 factorial over 6 factorial, 4 factorial, x to the 12th, 1 over x to the 4th, which is going to be your x to the 8th, which is what we wanted. Yay, we got there. And then 10 factorial is 10 times 9 times 8 times 7 times 6 factorial. And this becomes 4 times 3 times 2 times 1. 4 times 2 is 8. 3 goes into 9 3 times, and I'm left with 10 times 3 times 7, which is 210x to the 8th. Yes.
So the reason we did the whole R, or the 2R, that left side is because we want x to the 8th, and it's.
We wanted the x to the 8th term, but we knew that this was going to add and this was going to subtract, essentially. So we had to figure out which term that really was.
So when we did that on the left problem, it wasn't really that we were like looking for the 5th term per se, but it was we're looking for x, and we just happened to not have to do that process.
Yeah, we got lucky because
There's just
these aren't the same term, essentially, whereas they kind of are here. Yeah, that was a good one, huh? Well, we're done. Okay, so that's the last new thing that I'm going to teach you guys. We're going to spend the rest of the time talking about the reviews. So, question. There's a quiz tomorrow. The quiz tomorrow is going to be on 8.3 and 8.6.
Last quiz.
I don't know, maybe.
Let's do review.
Quiz, not
The
every
review.
day.
Need to review.
Just like random questions every day.
So the question is, what do you guys want to do tomorrow? So we'll have our quiz tomorrow, and then the rest of the time, what would you like to do? Well,
Let's go through it all.
I'd like to do a mock final.
so we can do a mock final either tomorrow or Thursday.
Let's do
I
tomorrow.
think, I'm pretty sure, but I'm not 100% sure, that I have some old Salt Lake Community College Math 1050 finals. Now the problem is, they normally take 2 hours to do.
You should just give it to us for homework.
Yeah,
No, but I think it would be good for you to treat it as a real test. So, but what I can do is I can give you, say, an hour to an hour and a half. I guess it would be up to you if you wanted to go 60 or 90 minutes. And then we could spend the rest of the time where you're like, I don't know how to do problem this or whatever.
Yeah.
Now the other, actually, let's do this. We'll do our mock final on Wednesday. Okay? So I'll give you one of my old Salt Lake Community College that hopefully I can find. I haven't taught there for a few years, but I'm pretty sure I have some. So we'll spend 60 to 90 minutes. I will let you guys kind of decide how long you want to spend, and then we will spend the rest of the time answering. tomorrow, here's what I would like to do. I did post the review, the UVU review that they sent out to me a few weeks ago. How many of you had a chance to look at that? 1, 2, 3, 4. Okay. So what I would encourage you to do, in addition to tonight's homework, so we'll still have our quiz tomorrow. Look at that review and then say, come to class and say, I don't know how to do this. I think that is a really good review. And then we'll just spend the rest of the time going over that review. And then Wednesday, we'll have a practice final. We'll spend, here's what I will say. Well, it's kind of up to you. We'll spend 60 to 90 minutes just treating it like a real test. Let's say 60 minutes. Because I think after 60 minutes, you're gonna have an idea of what you know and what you don't know. And then we can spend the rest of the time, because clearly you won't have time to do the whole thing in 60 minutes, I understand that. But you will be able to look at all the problems and say, that one caught me off guard, okay? And so we'll do that. So that's what we'll do. Thursday, I'm just gonna come in. I would love to give you the full 2 hours, but we have another class after here, so we probably still have to. So I will try to get here as close to 10-2 as possible. And well, for Thursday for sure. I will try very hard to start passing them out at 10-2 so you can have a full 2 hours. So if you can get here by 10-2, then you'll get exactly 2 hours. And if not, you'll get an hour and 50 minutes, which is what they would normally do anyway. But okay. So do you have any questions for me today? Do you want to go early? Yes.
It's just have like more curious question. So it's 20 questions for the final. Will they be easier than the test questions?
I'm not writing. So I think my test questions are pretty fair. I do think that review that they did is a really good review. I will tell you this. So I had a niece. So I've taught at Salt Lake Community College. I've taught here. I had a niece that went to BYU. I think Salt Lake, they're all very similar in level of difficulty. I would say Slick is slightly easier in this class, and BYU is slightly harder. So, but they're very, very similar in difficulty. So, any other questions? Okay. All right. Well, so just as a quick reminder, we'll come in, we'll do the quiz, or we'll answer questions. If you wanted to answer questions, we'll do the questions, then we'll do the quiz, and then we'll go over the review that I've already posted for tomorrow. So, all right. See y'all tomorrow.